Good morning. Assalamualaikum. Today we shall proceed to the final subtopic in chapter 3, which is combustion process monitoring and analysis. Okay, so basically we will monitor whether in your flue gas, what is the mole fraction of the flue gas, how much is the volume percentage, and is there any excess air in your flue gas? Okay. So from the excess air percentage, we can know how much of excess air has been supplied. Okay, basically, this is why you need to monitor inflammatory process. It is a routine monitoring. It is a routine monitoring to know whether your combustion process is successful or not. Is there any hazardous pollutants released? Okay, whether it is complete or incomplete. Ensure the process variables within the specified limit. Means if CO is released, so whether it is in follow the standard or not. CO2 release, does it follow the standard? Okay, to detect the abnormal process operation and diagnose the root of the cause. If your process supposed to be complete, but suddenly you detect a CO in your flue gas. So from there, you can know your combustion has some issue. Perhaps not enough air or something wrong with your combustion. Okay, preventive monitoring. Detect the abnormal situations early enough. So you can detect at early stage to avoid any bigger issue. Process optimization is to ensure that the process is operated at its optimum level. So for example, your combustion, let's say it can, the combustion, the fuel can be completely combust, for example, at 500 degrees C. But then your combustion process shows 800 degrees C. So there is excess of heat supplied over there. So you should identify for process optimization. Okay, so this is the benefit of process monitoring, where you can have a better process control, reduce fuel costs, identify optimum operating point, reduce stack gas temperature, maximize efficiency, and minimize the stack losses, minimize the pollutant release, and also protect the equipment. Okay, so all of these involve the cost as well. Okay, these are the common monitoring variables where in industry they commonly monitor the fuel and air flow rate. We know that combustion is mainly about fuel and the air. If not enough fuel, you have problem. If you have excess air, you will also need to consider the size of the blower, perhaps to supply the air. Okay, stack gas temperature, stack gas composition. So this is the common key performance variables where in this chapter we will focus on the combustion efficiency. This is the new part. We will also came across on the excess air calculation, air fuel ratio. Okay, the efficiency is the new part. The rest is the repetition from previous topic. Now this is equation to calculate the excess air, where it involves the AF actual minus AF start over start. Okay, we know that this AF equation okay, this is the AF equation, where in this actual and start case, we can cancel out the same amount. So for molecular weight of air, molecular weight of fuel, and 4.76. So leaving only the A. So if you simplify the equation, you can also use in terms of the A actual minus A start over A actual. Sorry, A start. Okay, in terms of the A. Okay, now just now is excess air in terms of AF. Now we can also calculate excess air in terms of equivalence ratio. From the previous excess air equation, okay, which involve the AF, when you expand this equation, you will get this, right? Expand the equation. Okay, so this part goes to 1. This part, where the AF actual over AF start. How this part can be related with the equivalence ratio? What is equivalence ratio equation? Huh? AF start over AF actual. Okay, so this is equivalence ratio. Now, equivalence ratio start over actual. Now this part is actual over start. So from here, we can simplify using the equivalence ratio equation. You'll get this excess air equation. Relates with the equivalence ratio. Let's say if the equation is not given, so you can derive and generate based on the previous equation used. For example, like this one, excess air. So from excess air equation, you can get also the equivalence ratio values. Any question? Yeah. Okay, in on-site, it always measured in dry basis. because the measurement of the dry volumetric concentration, either CO2 or oxygen in the flue gases. You will have a gas analyzer. Usually the gas analyzer, it will detect flue gases in dry gases. So this value can be can be used to calculate the air-fuel ratio. Then from there you can get the excess air if the composition of the fuel is known. Okay, and the combustion assume complete. Okay, the molar percentage of oxygen or carbon dioxide in the flue gas influenced by the level of excess air and also by the CH ratio in the fuel. Okay, so basically, as we all know from the combustion equation, the CO2 and the O2 is influenced by the fuel. Okay, we know that CX for the fuel air. So you have X CO2 plus H2O. Okay, plus O2 if you have the excess air over here. So this CO2 and O2 is influenced by your fuel. Amount of the air required is also influenced by the fuel. Okay, because for the air required, you need to calculate the A over here, right? So this A, again, refer back to the fuel. Okay, so that's why in the first topic, we analyze on the fuel part. Because we need to identify the properties of the fuel, molecular of the fuel, in order to know how much of CO2 and other gases produced in the flue gases. Okay. Now for gas composition analysis, consider a stoichiometric combustion of methane, CH4, with air. Okay, the composition of stoichiometric combustion product, this one, it already gives you CO2, N2, and H2O. Okay, so this is the combustion equation. What is the A? 2. How do you get? 5 plus 4 divided by 4. Yes. Okay, so this A equals to 2. Now, from here, we consider the total moles product gases in. Okay, this one is water in vapor phase or condensed liquid. And total mole of CO2 produced, which is 1, okay, plus mole of N2 and mole of H2O. Find out the total mole. Then from there, you can get wet and dry basis. This one should be dry. And total 8.52. This one is dry basis, wet basis. Okay, this part also we had done earlier in the previous subtopic. This is how to calculate the mole fraction of the gases in the flue gas stream, okay, where, for example, CO2, which is 1 mole just now, 1 over the N total. This one is for wet and this one N total for dry. So you'll get the percentage of CO2 in dry. Okay, so the instrument, the gas analyzer, usually it will remove water vapor from the mixture. That means it gives the reading in dry basis. Okay. Now we consider the combustion just now with 20% of excess air. 20% excess air. Just now export. Now we have 20% of excess air. Complete combustion, you produce this where you have O2 in your flue gas. Okay, giving a total product moles, the new N total, wet and dry. Because you have the O2. Okay. Then in the flue gas, this is how you report the analysis, the composition of your flue gases in dry basis and in wet basis. Okay. Now this is a compilation of without excess air, no excess air, and with 20% of excess air. Can see the difference. There are difference in mole number. Okay. O2, no excess air, of course, there will be no O2 in your flue gas. Okay. Next, we go to example one, where consider fuel ethanol combustion, go for combustion process with the air. Okay, the flue gas analysis, it shows dry O2 composition of 4%. So O2 in dry basis, equivalent to 4% O2. It asks you to determine the percentage of excess air. Then you need to determine the composition of CO2 in the wet basis. Okay, what is the first step? This process, it has ethanol burned with air. Then you have CO2, H2O, O2, and 2 in your flue gas. So this O2, 4% dry basis. Okay, 4% over here means the O2 O2 fraction, O2 mole divided by N total dry. Then you get the 4%. Okay. Now it asks you to determine the percentage of excess air. First thing first, always write the combustion equation first. Okay, what is the A over here? Remember, your fuel has O. What is the fuel? The A, sorry. What is the A over here? Your fuel CHO. What do you get for your A? 3, yes. CO2? How many CO2? 2. H2O? 3. Y over 2, right? So Y refers to the H. 6, huh? So 6 over 2. So you get 3. Now O2 is unknown. We put as B. Now this one you can calculate 3.76 multiplied by the A. In order to determine the excess air, what are the inputs that you require? How to determine the excess air? Which equation that you need to use? If we use this equation, we don't have the equivalence ratio. Can you use the AF equation? Which equation that you need to use? AF or the equivalence ratio? From here, in the previous slide, I mentioned that you can simplify the AF into A actual AS, then AS. Okay, so from here, you will get Right. Now from here, A actual. Where is A actual? Okay, 3 here, 3 that you get over here is A star. How to get A actual? So here you will have unknown of A actual also. How to get the A actual? Huh? Okay. Molecular weight of air over fuel. No, not from there. Okay. The A as we calculated is 3. Now, from the first equation over here, how many unknowns that you have for the actual? How many unknowns for the actual that you have from the combustion equation over here? Do you know the A actual? Do you know the B? No, right. So, next up. Huh? Balance. Do the balance. Do the balance in order to get the A actual and B first. Then only you can proceed with this excess air calculation. Okay? Then A actual of here is unknown. So we need to find the A actual first. How to find the A actual? A actual and B. You need to do the balance. It will involve two equations. Okay? Try to do the O balance. You will have first equation. Okay, this is the first equation from the O balance. Now another equation, how can you calculate? We need another equation in order to solve the two unknowns. The what? N total. N total and also from this info, the 4% over here. Okay, the info from the 4% of O2 in the flue gas. Okay, so O2 in flue gas is determined as 4%, where we know that from this equation. Okay, using this. So the O2 over here B over N total dry is equivalent to 0.04. Okay, so the N total dry, you sum up 2 plus B plus 3.768. Okay, so from here you will get the second equation. Simplify it, then you will get the second equation. Equation 1, A equals to 3 plus B. So you input equation 1 into here, then from there you can calculate what is your B. Okay, try to calculate the A and B first. Once you obtain the A actual, then you can input in this excess air equation. Then from there you can get what is the excess air percentage. Okay. Bear in mind, the one that we are calculating over here is A actual. Don't get yourself confused. What do you get for A? 3.65. 561 or 651? 3.651. 651. Okay. And this one is A actual. Okay. B 0.6561. Okay, so this is B, A actual. So to find the excess air, input the A actual over the AS, which is 3, minus 1, so you will get roughly around 20%. Okay, that one is for excess air. Now the question wants you to also calculate composition of CO2 in wet basis. Okay, CO2 in wet basis. CO2, we know it is it is 2. Okay, from this equation, 2 wet basis, so N total for wet 2 plus 3 plus the B plus 3.768. Okay, try to calculate what you get. So what you get for CO2 in wet basis? Zero point one. 0.102. Okay, roughly 0.1. Okay, the calculation looks simple, but sometimes you might make the mistake on the N total over here. N dry and N wet. So make sure N dry is without the H2O. Without the H2O. N wet is with H2O. Okay. The question for this example. Now we move to example 2, where you have a mixture of fuel. Mixture of fuel, you have propane, butane, propane and butane. Propane is 70% and butane is 30%. Zero point 0.7 propane plus 0.3 butane. That is your fuel. Okay, assume complete combustion. So the question over here, it asks you to find the excess air. So we assume complete combustion. If you have excess air, you will have O2 in your product. Okay, now for A, it asks you to find the swipe air fuel ratio. Swipe air fuel ratio. I would advise you to generate the combustion equation first. Okay, since this is a mixture, it's either you can directly write the mixture of fuel like this, or you can find one chemical formula. What I mean by one chemical formula is find out for 0.7, this is for propane. So times 3 plus 0.3 multiplied by 4. This is the carbon from butane. So you'll get one value over here. For H, the same thing. Find out the H from propane, which is only 70%, plus 30% from the butane. So you will get one value of the H. So either you use this kind of formula, or you directly find one formula of CH, or the new fuel. Okay, for A, we are focusing on the stoic first. So in the flue gas, no water yet. Find the A stoic. This is A stoic. Okay, first you find what is the A stoic, then you can find the air fuel ratio stoic. Okay, try to calculate that first. Okay, what you get for AF sort over here? 15.61. Okay, even though it is in the slide, you should try to calculate. Now, once you get the AF spot, go for B, where the given percentage excess air present if dry analysis shows 9% of O2 by volume. So O2 in the flue gas in dry basis, similar to the previous example, same step. Now it is 9%. Okay, try to calculate what is the percentage of excess air. Okay, for the B percentage of excess air, you should be getting around 68%. Okay, it depends to your decimal point use. 68 point something or 67 point something. Some get 69, but it depends to your decimal point that you use. Okay, but as long as it is in the range of, if you get 40, then you need to check your calculation. Okay, any question related this example? Can I? Okay, for next part is before we proceed to the thermal efficiency, this part, if let's say the flue gas analysis that you have, it yields CO composition in dry basis. Okay, how are you going to determine the amount of air that is actually supplied, amount of air? What is the additional info that you need? Okay, first thing, when you see CO in your flue gas, what can you conclude? Conclusion, if you have CO in your flue gas, huh? Incomplete combustion. So what is the cost of complete combustion? Huh? CO2 plus H2O. No, I mean, what is the cost of the incomplete combustion? Why your combustion is incomplete? less air. Okay, less air for the combustion to occur. Other than that, rich fuel, less air, rich fuel. Okay, that is the root cause of your incomplete combustion. Other than this, that one is the basic one. Okay, now, how are you going to determine the amount of air that is actually supplied? Infos required to determine the amount of air. What are the infos required? When you check using the flue gas analyzer, you detect CO in your reading. So how you want to determine amount of air that is applied to your combustion process? What are the inputs that you require in order to calculate? Type of fuel. Why do you think you need type of fuel? Huh? Calculate the A. Okay. Calculate the A. Then do you need the fuel molecular formula? Need, right? Because you need to know how much of C is supplied. Other than that, what are the info that you require? Sorry? Huh? Air fuel equivalent. Sorry, equivalence ratio. Equivalence ratio also can. What info that you get from this equivalence ratio? What info that you get from equivalence ratio? Huh? A actual. Huh? You can calculate the A actual. So from equivalence ratio, you can get the A actual. Yes, correct. Then, other than this, the AF ratio is also can contribute to the identifying the amount of air fuel ratio. Because from air fuel ratio, we know what is the A used in the combustion equation. Any more? You think KP value is important? KP value. Why do you think it's important? The water gas shift fraction. Okay, because CO, when you have CO in your combustion, it is incomplete combustion, then it involves the water gas shift fraction. Yeah. That KP value is also contributing in order to determine the amount of air. Any more? Other than that? Okay, so I think you have, I hope you understand the general concept on how to monitor monitor the combustion process, how to calculate the excess air, the amount of air required. Our next subtopic is the thermal efficiency of the combustion system. Okay, this one, it will involve example of quite a long calculation. So I plan this to be done on next week, Tuesday class. Okay, we will start this on Tuesday class. Before I end the session, any question regarding to today's lecture? Make sure you know how to calculate all of this. Huh? Okay, that's all. Thank you.